project. In this video, we are going to explain about a project titled An Entropy Clustering Approach for Assessing Visual Quotient Difficulty. Now coming to the introduction part, to validate the effectiveness of the proposed approach, extensive experiments were conducted on diverse visual quotient answering datasets. The results demonstrated that the entropy clustering approach outperformed existing methods in accurately assessing quotient difficulty. Furthermore, it exhibited robustness in handling complex and diverse quotient structures, ensuring its practical applicability in real-world scenarios. The entropy clustering approach introduces a promising technique for assessing a visual quotient difficulty. By employing entropy as a measure, this method effectively captures the varying levels of uncertainty in the relationship between visual content and associated quotients, thus enabling better understanding and categorization of quotient difficulty in computer vision tasks. Quotients with similar difficulty levels are grouped together, while quotients that exhibit distinct characteristics are placed in separate clusters. This clustering process provides a comprehensive understanding of distribution of quotient difficulty in the dataset, offering valuable insights into the heterogeneity of the quotients. So our main objective for this project, the entropy clustering approach for assessing visual quotient difficulty, is to develop a robust and effective method that can accurately categorize visual quotients based on their level of difficulty. The approach aims to address the challenges of determining the complexity of visual quotients in computer vision tasks, such as visual quotient answering, image understanding, and object recognition. First, quantify difficulty. The primary objective is to quantify the difficulty level of visual quotients in a given dataset. By leveraging the concept of entropy, the approach aims to measure the uncertainty or information content present in the visual quotients, providing a numerical representation of their difficulty. Second, we have feature extraction. The approach involves extracting relevant features from both the visual content, that is images, and the associated quotients. These features are used to construct a high-dimensional data space that captures the relationship between the visual content and the quotients. And the last one, we have real-world applicability. The approach aims to be applicable in real-world scenarios where visual quotient difficulty assessment is crucial for various computer vision applications. It is designed to handle complex and diverse quotient structures, making it practical and reliable for use in different environments. Now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirement. In hardware requirement, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. Now coming to the methodology part, first we have load VQA models. Here VQA stands for visual quotient answering, which in a data set is the field of artificial intelligence and computer vision. It involves answering questions about an image. To perform VQA, you need pre-trained models that can understand both the visual content of an image and the textual content of an question and provide an answer. The first step is to load these pre-trained VQA models into memory or the computational environment you are using. Second, question. In the context of VQA, question refers to the textual input that the model will use to generate an answer. It is a natural language question such as, what color is the car? Or how many people are there in the picture? Third, image path. Here, image path refers to the location or file path of the image that corresponds to the question. The image is the visual input that the VQA model will use to process the question and generate an answer. The image is visually provided as an input to the VQA model in the form of an image file or a URL pointing to the image location. Fourth, run entropy-based VQA clustering. Entropy is a concept from information theory that measures the uncertainty or randomness in a set of data. In the context of VQA, entropy-based VQA clustering suggests that the VQA models generate multiple answers for a given question, and these answers are then clustered based on their entropy values. High entropy indicates more diverse and uncertain answers, while a low entropy indicates more consistent and confident answers. The process of run entropy-based VQA clustering involves obtaining multiple answers from the VQA models for a given question and then grouping their answers into clusters based on their entropy scores. Fifth, clustering entropy graph. The clustering entropy graph is a visual representation that shows how the answers from the VQA models are clustered based on their entropy values. Each cluster will have a set of answers with similar entropy scores, indicating how diverse or consistent the answers are for a particular question. The graph may plot entropy values on one axis and the number of answers in each cluster on the other axis, showing the distribution of answers across different levels of uncertainty. 6. Accuracy graph. The accuracy graph is a visual representation that illustrates the performance of the weak way models based on the accuracy in providing correct answers. It may involve evaluating the weak way models on a dataset of questions and corresponding ground truth answers, and then plotting the accuracy of each model on the graph. The graph may have different models representing as different lines or bars, allowing a comparison of their performance. Now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder named as models. In this we have some files that are JSON files. And in this folder we have some images for testing it. In this data text file we have some data over here. And this is the main Python file which are containing the Python script in it. This is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. Here this is the graphical user interface. With this we are interacting with the program. Now click on load VQA models over here. And here you can see VQA model loaded. Now here we have a data set. From this file, we have to choose a question. Suppose here I am choosing, where is he looking? Here I am selecting this question and putting over here. And then in this image path, we have to upload the path of the image. So here I am selecting this image path. And now we have to click on run entropy based VQA clustering. So here in this image you can see that the image has been displayed over here and answers from all VQA as the person is skating over here, and in text area we can see question and we can see answers from VQA algorithms with entropy values. In this image also you can see the printing of answers over here. Now closing this graph, click on clustering entropy graph button to get the entropy graph. So here in this graph, x-axis represents algorithm name and y-axis represents entropy values. And in all algorithms, BTECH got less accuracy. Now closing this graph, click on accuracy graph button to get the graph. So here x-axis represents algorithm names and y-axis represents accuracy. And in all algorithms, BTECH got high accuracy and some algorithms got accuracy as 0. Similarly, you can paste questions and image path and then got answer from all the algorithms. So now closing this graph and coming back to the conclusion part. The entropy clustering approach proves to be a valuable addition to the field of computer vision as it addresses the challenge of visual quotient difficulty assessment effectively. Its ability to measure uncertainty and categorize questions based on their complexity empowers researchers and practitioners to build more advanced and capable computer vision models, thereby contributing to the advancement of the entire computer vision domain. The experiments conducted on diverse visual question answering datasets demonstrate the superiority of the entropy clustering approach over existing methods. It showcases robust performance in accurately assessing question difficulty even in the face of complex and diverse question structures.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.